Phase diagrams. A phase diagram is like a map of the phase, the physical state, solid, liquid, gas, of a substance at different pressures and temperatures. So we're going to show pressure on the y-axis, temperature on the x-axis. There are regions in the phase diagram that represent where a particular state is stable. There are lines or curves that show when the transition between those states happens. So there's a vaporization curve, a sublimation curve, and a fusion curve. Let's just look at this one real quick, and then we'll come back to that video. So this is a phase diagram for water. We have pressure on the y-axis, temperature on the x-axis. Note this is not to scale. But let's say we have, it's 21 degrees Celsius and 1 atmosphere of pressure. Well, let's find that on here. So 21 would be about here. And this is the line for 1 atmosphere of pressure. So what state should water be under these conditions? What's this region labeled? A liquid, right? If I had a temperature that was lower, minus 30 or something, this is going to tell me that that's going to be a solid there. And so that you might say, well, we know the melting point and the boiling point, so what's so special about that? But the other thing that this shows is what happens if we change the pressure. So at 0 degrees Celsius, if at a low pressure, water will be in the gas state. And as we go to a higher pressure, it will condense. And then as we put pressure on it will deposit. As we put pressure on the solid, it will actually begin to melt again. This is called the triple point, which is the point in pressure and temperature where you can have all three states existing together: a solid, a liquid, and a gas. That just kind of sounds impossible, doesn't it? So this is a demo with tertiary butyl alcohol. So they're pumping it out, I believe. Maybe they're not, maybe. I can't remember now. So there we've got the water boiling. Standard vacuum setup. Okay, so what they're doing here is they've got a vacuum pump hooked up and they're lowering the pressure inside this flask. And so there it got to the point where it would boil. We keep lowering the pressure and keep lowering the pressure, and then we get to the triple point. That's the liquid freezing. So there's liquid and solid together, and it's boiling. There's gas, liquid, and solid of the same substance all present together. And that's called the triple point. Isn't that weird? That was really weird. Yeah, it doesn't really, that's the highlight of it right there. Oops. You can find all kinds of fun stuff. Whoops. That's not what I want. I want this. So that's the triple point. Also labeled here is the critical point. So at any temperature above that critical temperature, you cannot have a liquid. You're going to have a supercritical fluid. So we talk about navigating a phase diagram, and the ACS exam does have questions about phase diagrams on it, so that's part of why I'm going over this. We can look at changes in temperature or pressure and see what happens as we change them. So here, if we're at a constant pressure and we increase the temperature, we see that water goes from a solid to a liquid and then to a gas. If we keep it at a constant temperature and decrease the pressure, we see that the water will begin to boil. It will turn into the gas state at a certain pressure. So look at this line. You see this line has a negative slope, right? That's the fusion curve for water, and that's unusual. Most substances have a fusion curve with a positive slope. So what happens there is at a constant temperature, as you increase the pressure, the liquid will become a solid. That's what most things do. Of course, water is not most things. So with water, as you increase the pressure, a solid will become a liquid. And this is how ice skates work. So yes, ice is slippery, but ice is not slippery enough to do all those things that they do on the ice, right? And I know, you may not be familiar with ice skates because this is California, not Minnesota. But if you look at the end of an ice skate blade, it's actually not flat or just a point on the bottom. There's actually a point on each side. So there's two edges of the blade. And what that means is that all the weight of the skater is pressing down on a very small surface area, meaning the pressure is really high. And so on the ice rink, that amount of pressure is enough to cause a layer of water at the surface to melt. And water on ice is much slipperier than just plain ice. And that's what allows ice skates to glide so nicely. That was a bonus piece of information. So this is a phase diagram for iodine. This is one for carbon dioxide. Interesting thing about carbon dioxide is at 1 atmosphere, there is no temperature at which the liquid is stable. None. You can't have a stable liquid until you get up to 5 atmospheres, which is really quite a high pressure.